Okay, good evening, guys. What, the saying, well, you may not know the saying, it may be a very Western American saying, when it rains, it pours. The last few days have been a return to Kafka. I think you knew that I moved into a place a month ago. Turns out the rental agent is a scammer. And we learned a couple days ago that the owner received none of the rental payments and none of that stuff. So had to move in the last couple of had basically 1 day to move because I just couldn't come up with the deposit since the owner reasonably expected to get paid for renting out her unit. So yeah, it's just crazy. So I moved again and then this place had problems, so we're moving again upstairs. I'm not sure what part of, we're eastern Bangkok or something. So anyway, it's been a crazy few days. So I'd hoped to get this narrated version of things to you in advance of tomorrow. So my apologies for that. I hope that you can find the time to at least catch this first part. I'm gonna post two. I'm gonna be working late tonight. So anyway, that's the plan. What I want to do is spend some time getting you to kind of get into your focus what it means to try to think about, represent, and use complex data. We're going to start very simply, and then build towards a greater and greater level of complexity to show both the challenges and the payoffs of doing so. So this is titled Climate, Complexity, and Resilience, Saving Your Planet One Incomprehensible Equation at a time. That's meant to be, sort of sarcastic because it's entirely comprehensible. But what we're going to do today, or this first part, is actually kind of hold off on using climate data to, you'll see kind of, as I said, we're going to kind of conclude at the end with this interactivity between our social problems. So we're at this turning point. We're seeing complexity at work on and among the three wicked social problems of the course: conflict, poverty, development, and climate. Right? What I want us to do is start to think about how these are interactive problematiques. They're not discrete problems as we would perhaps prefer, right? But first, just a word about modeling. Well, just some kind of basic concepts, three basic concepts that I think we can remind ourselves of. I'm assuming everyone's had methods by now. So just the idea of modeling, right? Scientific explanation, right? What does it mean to say we're trying to explain something, right? Fancy words we're not going to use like explicandum or explanandum and all that, explicans and all that. We're not going to go there, but those are actually quite useful terms. But basically all we're thinking about here is any attempt, any effort to try to account for why something happens, or to be able to tell others in what ways things unfold, or identifying the conditions under which that which we're interested in is likely to happen, reoccur, or not, right? So to explain is to offer an accounting for the why of something, the how perhaps of something, or the when of something. So nothing obtuse about that. To show the causes of things, or to show that this causes such and such to be as it is, right? So and of course, if you've all had methods, establishing causality is no mean task. But we're gonna, this is not a philosophy of science course. We're gonna kind of have to just stipulate a certain number of things about that. That's quite all right there. So modeling is one very common, most useful way of doing scientific explanation. What does it mean to say we model something, or we're doing or engaging in the practice of modeling? Well, we've all perhaps built models of something as a kid. Actually, even kind of into adulthood, I used to model World War II aircraft. I'm not sure why, but so we know what a model is in some sense. If we think of a model that I used to build, or kids build, model trains, model cars, model whatever, right? They're representations of something real, but they're not real, right? They don't capture and can't possibly capture all the complexity of the real thing, right? So that's kind of important to keep in mind. When we say we're modeling something, we are in essence confessing or conceding that we're not saying everything that can be said or that's important. It's the generation of a physical, conceptual, or mathematical representation of some real phenomenon that is simply, impossibly difficult to sometimes observe and recreate for someone directly. And I've written on this, I've published on this matter of how we can try to tap into data that is in some ways experientially costly to gather. This was my theory of conflict early warning. So I've been thinking about the issues of trying to engage with and represent real problems in an abstract modeling sort of way. And then lastly, prediction is what makes, or what follows, or is what made, prediction is that which is made possible by doing good scientific explanation and building good models, right? So what is to predict? And remember, if you haven't had a chance to look at it yet, you're strongly encouraged to look at Nate Silver's work on prediction. He's just got some great things to say. But basically, we're talking about a guess, right? About a future state of affairs or a condition. But it is not a haphazard, random, pull something out of a hat kind of guess, right? Because much of, I think, the popular world has that sense about science, particularly if scientists are talking about things that unsettle them, like climate change, right? They start to think that scientists, are in the business of just the term theory in the kind of rest of the world tends to mean something of little value. If you think about that classic kind of opposition people tend to make, theory versus reality. Right? In theory, that may be a good idea, but my experience says X, right? That's not the way scientists use, as you now know as seniors. That's not what theory means, right? So the prediction that we're talking about in a scientific fashion is a guess about a future state of affairs that is based on observations from perhaps past data or present data, or both, hopefully, as well as the rigorous analysis of that data, looking for patterns and causal relationships. So it is never what the naysayers say. I mean, it doesn't mean the predictions are right, but they are never these sort of random, haphazard, throw a dart at the wall and see where it lands kind of thing. Prediction has never meant that in a scientific way. So let's embark on this turning point, right? By thinking quite directly about modeling and explanation and prediction. But instead of starting with climate, I want us to kind of, because as I've been saying, we're going to keep these things together. They're not discrete problems. We're going to stay with, for the first part of this, with conflict. We're going to use conflict data to get you to think about what it means to complexify in order to simplify, taking us back, okay? All right, so it all and always begins with observation. That's how any sort of science, social science, humanities, and any kind of academic enterprise begins. It begins with just making observations that strike our curiosity, things that we may observe at home. As you've my students have heard me say, when we're thinking about research papers, particularly in my methods course, it's always best to just start with observations from your home, perhaps your home country, your home region, or that strike you as significant or important and puzzling, right? So an observation can be really quite basic, right? And in terms of conflicts, right? We can just start with one that says, not all conflicts are alike. And, that's just unarguably true. But, and many ways that one could observe that, right? If you just sort of ask yourself for a moment now, how might that be? How might conflicts differ from one another, right? Well, that's what I mean here when I say that observation itself starts to invite further questions and further observations. And then we end up asking questions like, how do conflicts differ? Or in what ways are conflicts different from each other? And we tend to think of these differences in terms of causes. What are the various causes of conflicts? I can't remember if I gave you to readers my Côte d'Ivoire report for the UN. And somewhere I quoted Tolstoy. He said all happy families are happy for the same reason. All unhappy families are unhappy for very particular reasons, right? And that's true of conflict, right? I mean, there are general explanations and general categories of causes, but at the end of the day, every conflict has its unique set of causes. What are the parties? Conflicts differ in terms of who engages in them, the number of parties to the conflict. How long does a conflict last? They vary greatly. I was hired essentially in the Côte d'Ivoire case because the war had gone on for 11 years by that time, and they were sorely trying to get a bead on why this damn thing just wouldn't die. So some conflicts are of relatively short duration. Some, as we've talked about, the intractable ones tend to go on for very long periods of time, and outcomes ultimately, right? Some conflicts lead to just simply mind-bogglingly atrocious outcomes, and some never reach that level. And these are the kinds of things that we want to be thinking about. And then ultimately, most significantly perhaps, is why do they differ? Why do conflicts differ in those ways? So once we can make the observations about how they differ, it becomes a question or a matter of trying to come to terms with what causes those differences to be, right? So let's just present you with some data, right? What we've got in front of you, right? What I'm presenting is conflict outcome data. Each dot on this graph represents two things. It represents a year, and it represents the number of people who died that year in violent armed conflict. So the bottom axis, it's kind of small, but it starts in 1940. But the first year of data is 1946, and it ends in 2016. Right? And on the up and down vertical or y-axis, which is what lists the number of deaths in that year. Right? So we've got 70 years of data recording global total yearly fatalities due to violent conflict. That's what you're looking at. Right? I'm asking you to sort of think scientifically, right? I want you to ask yourself, what observations can we make about these data? Right? What do you see that might explain, what do you see that might merit some explanation, merit some investment of our time and effort to offer explanations? Are there any discernible patterns that appear to you? Right? That's the way this all begins, right? So what I'd like you to do is pause this video for a few moments and just kind of reflect on what you see, and maybe jot down some notes, and then return and let's see what we come up with. Welcome back. Okay, so I'd be very keen to find and see what your list of notes are, but here's what I want us to think about, right? Lots of things we can say about the data. First of all, we can observe that there is, there are these individual data points, and one of them is the highest, the most the highest value, right? And that happens to be in the year 1950, and over 1 million people perished that year in conflict, right? 1,93,002 persons died that year in conflict. So the maximum value, that's one observation we can make. We've also observed the minimum value, right? In the year 2008 or 9, 31,105 recorded fatalities due to violent conflict. So we've got maximum and minimum values. Then we've got this, we're going to say more about this later, but then we've got this kind of off by itself sort of data point, right? So we've got in the year 1995, just under 600,000 deaths, right? And the fact that it's out there by itself is statistically and scientifically significant. We're going to call that an outlier at some point. So that's just another observation. What else can we? Well, I'm wondering what else do you see, right? Well, I would assume that you all saw that there's this basic sort of snake-like pattern at some level, right? Very high levels of conflict at the outset of this period, from 40 to the 70-year period, and then it dips quite low, and then goes back up, and then dips again, and then rises again. So there's crests and falls, and this sort of serpentine kind of pattern, right? I think that's pretty obvious, pretty easy to see. That level of observation can sometimes, if you've ever heard the expression, prevent us from seeing the forest because of the trees, right? So we can also see, or if we think about that short thing we watched, that short clip I showed you with Neil deGrasse Tyson, and climate versus weather, right? He was walking his Labrador retriever on the beach, and the lab was all over the place, right? And he said, that's kind of noise, that's weather. What you want to keep your eyes on is the man, he said. Don't watch the dog, watch the man. And because the dog seems to be pretty random, but the man was going in a particular direction. And that's the difference between weather and climate, he was saying. So we've got, as I think everyone can probably see, despite the serpentine pattern that's there, there's also a quite obvious general flow in the direction of yearly fatalities, in a good direction. It's going down, right? So yeah, I think lots of things here to see, okay? It is, in fact, what that green line is surprisingly, perhaps, if the first red arrow that people just saw seemed like a good representation or a good fit to the data. Statistically, numerically, that green dotted line is in fact the best fit. It's the one that minimizes the distance, or the square, actually, you don't have to remember that, the square of the distance of every data point to that line. It's called the best fit, the minimum least squares line, right? And that line has a formula, an equation associated with it, right? And I'm not going to let this freak you out if you're a math phobe, and you know what? I was a math phobe for many years, so I get it. There's nothing scary about that, as I'll show you in just a second. But the line that you see there, the green line that we're able to draw or create statistically is represented by an equation, and that is a model, right? So this equation for what's called the trend line or a regression line is in fact an example of what we mean by a model to simplify a very complex reality. Think about that serpentine pattern to the data. We're going to simplify that down to a kind of core reality, which is that best fit line, right? And that equation, y equals negative 5, 3, 6, 7x plus, now that 1e plus 0.7 is simply a very long set of decimals, right? That's just scientific notation because the actual number, I used Excel spreadsheet to create these, and it doesn't like to give you, 10, 15 decimal points. So don't let that, and we don't need to know, how to do all of this stuff in this course, but just to remind you, all that, scary looking equation is just a representation of that line in terms of the direction in which it flows, the angle at which it, proceeds from left to right, or through time, or whatever the data might be, and whether it's a positive or negative direction. If it were an upward, if conflict fatalities were growing over this 70-year period, that green dotted line would be what? It would be headed to the upper right rather than from upper left to lower right. So the fact that it's a negative 5, 3, 6, 7x means it's a downward sloping line. It's a good thing in this case, right? So just to remind you, just in the simplest terms, the formula that you see there, the y equals negative 5, 3, 6, 7x, is just taken from what you learned in algebra all those years ago, the slope-intercept formula for a line, y equals ax plus b. So if you just have, just to remind you, if you just give values, if the x value is 2 and the y value is 1, then you've got a red dot there. And if you have an x value of 3 and a y value of 2, you've got a dot there, and then you can draw a line to that. It'll cross the y-axis at some point. That's what the b is. That's the y-intercept. And you've got the representation of that line in two-dimensional space. And every line has an equation that would do that, right? That's all that is. We don't need to go beyond that. And it's okay if that still seems a little freaky. It won't, I think, be at all intimidating by the end of this. Below it, there's another number, r squared. Again, this is not a stats course, and I make no assumptions that you've had, or actually I should make the assumption that you've had no stats. So all that r squared does is tell you how, I told you that green dotted line is the best fit line, or the least squares regression line, right? Meaning it's the line that fits the data the best. And statistically, I said that means if you take the distance of each data point to that line, square it, sum them all up, that line makes that total, that sum of squares, as small as possible. It's the best fit to the data, right? So the r squared tells us, okay, that how good of a fit. It may be the best fit possible, but is it a good one? Not necessarily, right? You can fit a line to any set of data. It doesn't mean it's a good fit. It doesn't mean you've got a good, strong, say, explanation going. And just to tell you that r squared of 0.223 is not great, right? Meaning it's not the best fit you could hope for. Now, why might that be? Ask yourself, just looking at this data, why might that not be such a great fit? Was anybody surprised the way that green line got generated when I first had that red arrow that was kind of above it, right? The problem you may see is you've got those early years with very high fatality numbers, right? If you think about it, that probably has a pretty big impact on where that line crosses the y-intercept. It pulls it up in a kind of exaggerated way, right? It sort of overestimates for the 70-year period what a normal average expectation for yearly fatalities ought to be, right? If we've got 70 years of data and all but about 6 or 7 of those years are below 600,000, but we've got these really big numbers, million, almost a million, over 800,000. We've sort of artificially or inappropriately lifted that best fit line. And that's what that r squared tells us, is that line is not a great fit. We've got some data that make it hard to draw a best fit line that's a good fit line, if you will, right? And we'll kind of say some more about that in a bit. Okay, that's all that. All right, so no problems, okay? It is on the basis of this equation or this model, however, that we can attempt prediction. And the reason I've just taken you through this sort of, is it a good fit? Why do I give you the r squared and tell you what that means? And in this case, that it's not a great fit to the data, right? It is because it is on a basis of the equation or the model for that data, the line that's drawn to fit that data as best as possible, that we can attempt prediction about future states of affairs, right? That's the whole game in climate, isn't it, right? So what does the equation that we are given for this data set allow us to predict into the future? So I ran a 15-year forecast, a 15-year prediction to see what yearly fatalities might look like in the year 2030, 15 years back from the last point of data in 2016. So it's a 15-year forecast. That's not a crazy long forecast in scientific terms. When we talk about climate, you're going to see some longer ones. And what do we have, right? Well, if you look, right, the prediction based on the model that we have for this data is that in the year 2030, we'll have 0 fatalities from conflict. Peace in our time. So, what do you think about that? Pretty cool, huh? But I ask you, really? You think so? How many of you were sold on that prediction? How many of you are confident that in the year 2030, war will, essentially it seems, become a thing of the past? We will have relegated armed conflict that kills people to the dustbin of history. I wish I could believe that. And I'm not a pessimist. I don't think that's a great prediction, right? Now, why is that, right? That's the, this is good. I'm not a terrible statistician. I'm not this is not my forte, but, I haven't made any mistakes here, right? What's wrong, right? Well, some might say, is that the only kind of line we could draw? Is that the only kind of model that we could construct to represent that model, that data? You'd be right for thinking so, because it's not, right? That, when I ask upon what assumption is the prediction predicated, you might say, well, it's predicated on the assumption that the trends of the 70 years that we have data for will continue. That's the most important assumption. And it's also a linearity assumption, right? That line is straight, right? And that's a linear equation, right? And that's not necessarily, you saw that serpentine, arrow follow that data. We don't have to resign ourselves to linear thinking, right? As the whole business of complexity has made us understand. So we can, in fact, estimate or calculate polynomial, they're called, equations or models to fit our data. And you can just right away, I think, perhaps see that that's a better fit than what we just had. Because it curves, because it's allowed to bend with the change in time in the data and the values of the data, we just instantly see that we have a better fit, right? Now, r squared still hasn't gone up very much. I mean, just a fraction, but we've still got, I think, a better model, right? The reason the r squared hasn't gone up much, the reason that best fit line still isn't a great fit, is the same problem, right? Those big data points, those really high value data points in the outset, and then that outlier in 95, really kind of just make it hard to estimate an equation, a model that would fit this data well, right? It's a complex world. It's a complex reality. Nevertheless, we can ask what kind of prediction we get from this polynomial equation or model. And what that one predicts in the year 2030 is a yearly fatality level of around 225,000. Peace in our time? No, I'm afraid not. I'm not a pessimist, but I think I'm more comfortable, sadly, with a prediction of perhaps approaching 250,000 people a year in the year 2030 than I am with zero, with having effectively ended war in our time. So I hope this is, now again, that scary, even more scary equation, right? Now that you have a polynomial equation, is essentially the same thing. It's just giving you a way to represent this data with that best fit line. It's just the line for an equation, it's the equation for a line that curves. That's all it is. That's why it's an x squared rather than just an x, but that's all you need to know. All right, so questions are, right? We said, we start with observations. We've done that. Now it's time to kind of think about this stuff from a scientific sort of perspective. Why? Why is it that we're seeing what we're seeing? What explains the variation in the data? Right? Why are some years so much more violent and kill so many more people than other years, right? That's, for me, as a student of conflict, the critical question in almost everything that I do. What explains why data is not consistent over time or over space, right? In the African context in particular, my students have heard me say that that's the central question that animates and has animated my research for 2 decades. It's like, why? Africa has this, very wrong reputation as being a continent of conflict. It's had more than its fair share, for God's sake, I won't deny that, right? But it's never been, is not, and has never been a continent of conflict. And that's what really screams out for explanation. Why, if country A, Liberia and Cote d'Ivoire and Sierra Leone and Ghana and Senegal all have all the same risk factors for conflict, for all the same reasons to kind of predict violent armed conflict, and yet Senegal and Ghana never had them in the way that Liberia, Sierra Leone, and Cote d'Ivoire did. To me, that's the most important scientific question. If they were all equally slated, if you were, for conflict, but 3 of them had it and 2 of them didn't, if we can come up with answers to that why question, we can improve the human condition. We can end the suffering, perhaps. Certainly lessen the suffering of a great many people. So how do we start to find or even seek answers to these kinds of questions, right? Well, I want us to remember, I'm actually in other venues, if you will, something of a critic of dominant conceptions of science. Science is not omniscient. It does not know and cannot know everything. And we should always remember that, and good scientists are never not aware of that, right? But what do data limitations mean? The fact that science can't tell us everything and with perfect precision does not mean it's worthless, right? Which is, as you'll see, quite a common reaction for those who find what it is that scientists may be talking about discomforting, right? So let's look at 2 very different visions here. I just had some fun with this. I hope you kind of see my point. 2 very different visions about what it means to recognize or be cognizant of the limitations of science, and maybe in terms of just the data that we have available, right, to answer questions that are important. Okay, so let's begin with this person first. This is John Freeman. I find this on Quora. I really have a love-hate relationship with Quora, actually. So John Freeman is in a comment thread here, and he's just saying, a few years back, it's a climate change thread, and he says, a few years back I had the idea it'd be a fairly straightforward, he said, which is an MIT, that's a university, expression that usually is a recipe for disaster, to estimate the net carbon balance, meaning, the kind of total level of CO2 in a given year by simply computing the total carbon emissions from the burning of fossil fuels versus the net uptake of carbon by plants and oceans. Remember, trees kind of suck up CO2. He says it seems simple. Just add up the surface area of forests and vegetated areas and agricultural areas and oceans from satellite data, and then estimate the output of coal mining and oil production, and then just subtract, right? The answer ought to tell whether man is screwing up the environment. He says this turned out not to be a, quote, well-posed mathematical question like the Drake equation. There are just too many unknown variables. Think about how many times we've had this come up in our discussions of complexity. I still think it's a worthy undertaking if we just had the facts, man. I like this guy. I've never met him, but I just think he's got a nice sense of humor. Absent the requisite hard data, we're stuck in a conflict between vested interests, meaning perhaps people that work for the oil industries, that sort of thing, and people who would like to see the planet survive our depredations, right? Like I've been saying. I fervently hope, he says, that the latter went out. And so good for you, Professor. It's, again, in a comment string initiated by a professor who's making some comments about climate change data. So that's John Freeman, right? I just want to point out, now, before I do, I want you to kind of rest assured, I hope you'll believe me when I say that I am not a credentialist, right? One of the things that bothered me and remained bothersome from my very first moments in Thailand, and Thailand's been really a marvelous experience in many ways. I've wanted home to my daughter all this time, but Thailand's been great to me. And but one thing's always bothered, and that's the kind of, America's this way a bit too, but just not nearly as much. Ajarn Brett. When I arrived, because I have a PhD, I was instantly given a certain level of credibility, and more than that, almost kind of judgments about my character and things are just not appropriate, right? And the ladies who cleaned my apartment after 3 years still couldn't call me Brett. It was Dr. This, or just. So I am not one of those people that think the credentials are the measure of a person, but they're not irrelevant when we're talking about, say, a scientific debate or questions of science, right? So what are his credentials, right? They're pretty damn impressive, right? Dr. Freeman is in fact, doctor in two ways. He's a medical doctor, and he holds a doctorate. He's a professor, a neurobiologist, a psychiatrist, and he's kind of joking, he's all-around sophist, a kind of one who loves to argue. Okay? If you look up to the right, a PhD in medical biophysics and electrical engineering from Massachusetts Institute of Technology, one of the finest, if not the finest, engineering institutions in the whole of the world, right? These guys' creds are serious, right? And remember what he's saying, right? He's saying, I just wanted to kind of take a position, or try to, that's not what I want to say. I want to kind of make a contribution, one narrow little contribution, one small slice to the whole climate change pie of questions, right? By asking, about what might be the net carbon balance, the result of, what would the resulting level of carbon dioxide in the atmosphere be if you had the data to kind of see how much we're putting out and how much is getting taken up by trees but we just didn't have the data to do it, and he just sort of concedes that he couldn't make that specific contribution to the whole climate change problematique that he had desired. We just don't have the facts, man. But hopefully we will at some point, he says, right? And in the meantime, I hope that those who want to see the planet survive win out over those who have other interests, right? So that's Dr. Freeman. Right? I don't know him, but I like him. Mr. Jason Siegel. Right? Mr. Siegel has a different take on what Dr. Freeman has to say. Right? Here's what he says, too. Now, he's speaking to Dr. Freeman, right? He says, I agree with your premise, and pardon all the purple stuff, that's just for you to think about if you wish. I agree with your premise, he says, but not your conclusion. You sound smart enough to correctly frame and solve a difficult problem, yet you were not able to do so in this case, presumably because the information you would need simply does not exist. Well, that's precisely what what Dr. Freeman conceded was that there were just so many unknown variables that he couldn't, in fact, articulate or estimate an equation that would have gotten anywhere near the kind of contribution he was trying to make. Again, a contribution that he recognized would be a small slice of the whole climate change pie problematique, right? So again, you weren't able to do this because the data you need simply doesn't exist, correct? Well, if you don't have that information that you need, then no climate scientist does either. And then the conclusion drawn from these propositions, that means climate change, the extent and causes, is an open question. You can probably tell that this guy just pisses me off, pardon my expression. Right? This is the sort of thing that will prevent your generation from meeting the challenge that we have unfairly shouldered you with. Right? I ask you to reflect on this. Maybe pause this video for a moment and look again, or back up and read what Dr. Freeman has to say, and then look at what Mr. Siegel has to say to him. Right? What Mr. Siegel is saying, right, is that because you could not make the contribution you wanted to make, answer the question you wanted to answer, which is a very narrow, very specific, right, question of the many hundreds of thousands, perhaps, questions all associated or under the umbrella, we might say, of climate change science, right? Because you couldn't answer that one very specific, narrowly tailored question of the many thousands about climate change that are out there, because you just couldn't get the data to account for all those variables, then we don't know anything about climate change. It's an open question as to whether it's even happening and what causes it, if it is. There are so many logical fallacies in Mr. Siegel's construction here. We don't have enough time in a geological scale to begin to count all of them, right? Suffice to say, Mr. Siegel is just bloody wrong to conclude or to infer from the preceding stipulations that we can say nothing or know nothing about climate change because Dr. Freeman could not answer that one particular question. That's just utterly, vacuously stupid, right? It's a fallacy of many, many kinds, in fact, right? In fact, I would argue that Mr. Siegel is a paradigm case of what we call the Dunning-Kruger effect. Now, again, credentials are not everything. Sometimes they're nothing, right? But if you compare the credentials of Dr. Freeman with Mr. Siegel, you can see that Mr. Siegel doesn't have any, right? It's not even clear that Mr. Siegel went to high school, right? Yet he is presumptuous enough to, well, praise the good professor for sounding smart enough. Note that he says you sound smart enough. You may not be smart enough, you just sound smart enough. Mr. Siegel is saying that because Dr. Freeman couldn't answer one specific question, we can know nothing and do know nothing about climate change, is what we know as an example of the Dunning-Kruger effect, which is basically, as psychologists have framed it, a cognitive bias in which people have such an enormous level of ignorance that it prevents them from being cognizant of their enormous level of ignorance. In other words, they're so ignorant of whatever it is that they need to know something about that they can't possibly grapple with, identify, appreciate their level of incompetence. Right? Mr. Siegel has no basis, it appears, right, to engage in this conversation as is demonstrated by the ultimately completely vacuous conclusion he reaches from just very spurious data. He is Dunning-Kruger effect, right? I am reminded by someone, my students from methods might remember my very complicated relationship with Sir Karl Popper. Years ago, Karl Popper was the enemy, as it were, when I was first starting to study the philosophy of science, and I've come, because of teaching methods here at Webster, actually, to have a very different view about Sir Karl Popper. He's a dogmatic, only one way to do science kind of guy, and that's not me. But I came to have a great deal of appreciation for Sir Karl, and one of the things that he said that I think a lot of and reflect upon often is this, and he says, as we learn from our mistakes, right, our knowledge grows. Even though we may never know, that is, to know for certain. Since our knowledge can grow, there can be no reason here for despair of reason. And since we can never know for certain, there can be no authority here for any claim to authority, or for conceit over our knowledge, or for smugness. I love that. Right? Now, I will say that Sir Karl could be rather smug at times, but what he has to say here is lovely, and I think very important for us to remember. It's just interesting to me if you compare the statement from Dr. Freeman about what he wanted to try to contribute to the climate change science, what he wasn't able to because of data limitations, and an openness about that, a humility about that, and then Mr. Siegel's absolute conceited smugness in his rejection of all of climate science simply because one professor, however enormously qualified he may be, couldn't answer one very specific question because of data deficiencies. It's the kind of smugness about and conceit about a claim to authoritative knowledge that is just massively ironic coming from Mr. Siegel. Okay? I think it's important that we remember what Popper has to say here as we move forward into the very, very complex world of putting these three interrelated problematiques together. Okay? I'm going to take a quick break just to solve my throat problem. So just taking a pause here. You won't notice. Okay, so let's get back to this. How do we find the answers? How do we seek explanations for the kinds of observations that we've made and the questions that they give rise to? Well, that's one thing we tend to talk about. One thing we can say is, and this is what complexity theory does particularly well, is it's often important to disaggregate the data. Now think about what I showed you, what we were working with. It was yearly casualty counts. The number of people who perished in violent conflict over the course of a 12-month period. We didn't say anything about what kinds of conflicts those were. And if we do, as this slide shows, right, we start to see some very important things emerge. Right? We recognize that one way in which conflicts differ are the parties to them. Right? And this conflict type is very much about who are the parties involved in the conflict. So we have state-based conflicts from 1940, again, all this, that 70-year period. We have one-sided violence. That's generally, what that generally means is, say, a government is committing violence against a group in society, or one group in society is committing violence against another group in society. And one side has the power to do so. So one-sided violence, non-state conflicts. Now these are when, let's say, the state, the country in some sense is starting to lose, the government there is losing the capacity to control affairs, and you may have, say, rebel factions fighting each other, or kind of conflict, violent conflict emerging among different sectors in a national population. So non-state conflicts. Interstate conflict. Now this is just what we always used to mean by war, right? One country fighting another. Other data, other charts would show you that that's really something that's almost disappeared, is almost in the dustbin of history. We have colonial imperial conflicts, also something, thankfully, largely in the dustbin of history. And we have civil conflicts, civil wars, right, that have a level of foreign state intervention. Now, I don't mean by this a peacekeeping kind of intervention, humanitarian intervention. No, this is intervention by one or multiple external states on one side or the other. So think of Syria today, and the results, the implications of Russia's siding with the Assad regime, for example. It was almost certain that Assad regime would fall. until Putin basically saved the Assad regime. And that made the intervention by the Americans on the side of those opposing the Assad regime ever more complicated. And it had the effect, as you well know, so this intervention of Russia and the U.S. In very different ways, but still intervention, had the effect, as it usually does, as we'll see in a bit, of extending the length of a conflict and, unfortunately, its magnitude in terms of human costs. And then there's just straightforward civil conflict, civil wars. Right? So we've got, as this chart shows, a great deal of variation, or a great deal of that variation we saw in the earlier charts, explained simply by understanding what kinds of conflicts we're talking about. Right? So one reason that serpentine shape in the data has a general downward trend is accounted for by the fact that interstate conflict is a form of conflict that has largely disappeared, right? Which is a good thing. Take this, for example, right? Another way to think about how we can explain what we see is what might be the relationship between the kind of, not the kind of conflict, as we just disaggregated the data in that term, but perhaps something about the way in which countries are governed. And not necessarily in this case, or this chart is not making that point, but rather the degree to which there is a reasonable or a high level of stability in governing, whether that government is authoritarian, like say Beijing, or liberal democratic, like Britain, France, or Sweden, or US, or whatever. What we're talking in this chart, what we're showing in this chart is systems of government that are in the process of changing from one to the other. And it goes in both directions, actually. In the last decade and a half, much of it has gone in the direction from democracy to back to authority, like Russia, for example, democratized, and then Putin kind of recreated many of the conditions of authoritarianism. Right? What this chart shows is, many of you perhaps heard of the democratic peace, that democracies don't fight each other, and then there's this kind of civil conflict dimension to that. What this chart shows is it's not about democracy or authoritarianism, it's about regime stability. If you want to predict which regimes are going to be, which countries are going to suffer conflict and that creates lots of casualties, you want to look for systems that are changing the kind of government they have in one direction or the other. It's that regime that doesn't enjoy consolidation that is associated with conflict. And so there's another factor, right? The second thing we can just do in general, right, is, there's no substitute for some library work or internet research. You need to review the scientific literature associated with the problem of climate or conflict or poverty to try to find out what we know already about, say, the risk factors. What tends to be associated? What other conditions correlate with the problem we're trying to address? Conflict, climate change, what have you, right? And it's been known for many, many years or presumed, I should say, for many, many years, that a key risk factor for conflict is economic inequality. And we've also known that there's been an alarming increase in economic inequality, both globally on the global scale, but also particularly in my country. I don't think there's another country in the, I could be wrong about this, but we're certainly at the very tip. We're close to the tip top if we're not the top. I don't think there's another country that surpasses the U.S. in the degree at which inequality is growing, defined in terms of the percentage of the population that owns, the size of the percentage of the population that owns, the bulk of the country's resources. So we know that economic inequality and the growth in that is strongly correlated with different modes of conflict, the kind of governance that you can expect, and what we're going to call societal capacity, right, which is a very important factor in its own right. So we start to look for other things, like what might help prevent conflict from being so destructive and create so many, casualties. And one thing that comes up again and again and again is the health and vitality of society, particularly civil society, organized, NGOs and community-based organizations. Those societies that have good, healthy civil, or those countries that have good, healthy civil societies tend to have much less conflict and much less destructive conflict. So mitigating factors, the reason I'm using these terms mitigating, mediating, is it's going to come up here in a moment. Mediating factors are those factors which can kind of influence the relationship between cause and effect that we know exists. Say, for example, what we were just kind of thinking about, inequality, right? If inequality, we know, has a positive correlation with conflict, what does it mean if that inequality is occurring or even growing in the context of a country with quite a stable regime versus that inequality taking place or growing within the context of a country whose system of government is undergoing radical transformation? The former is a mediating, this is a mediating factor. It can help, it can strengthen or weaken the effect of some other variable on some other outcome. So in this case, the level of regime stability can lessen inequality's likelihood of creating conflict with high casualties, or it can increase it depending on whether it's a stable or unstable regime. I hope this is making sense. We can all, of course we will talk about this in class. So mitigating, mediating factors. It also always helps to do comparative thinking. Let's get out of our box, right? Let's get out of our comfort zone. Let's get out of what we know and look at the rest of the world and look at it in terms of things we can, we say we can't compare apples and oranges. Well, that's just not true. They're both fruit, aren't they, right? So lots of ways that we can compare what is often dismissed as incomparable. Regional comparisons in terms of, say, war magnitude, conflict magnitude, reveal very important differences in the economic costs of war. It is very clear that the world's population, or those who constitute the world's population, do not bear equally or equitably the economic costs of war. And this slide shows just 3 regions: Sub-Saharan Africa, which has had an economic impact of conflict of $453 billion in this period. Asia Pacific at $3.38 trillion, right? And South Asia at $1.27 trillion. So just off the, from the very beginning, we can see that regionally, wars have varied in terms of what the economic costs have been for those regions. But I want you to take a look at what else these graphs, these diagrams reveal to us, and we see if we go from the region to the subregion to the per capita, right? We start to see that it is in fact South Asia or South Asians, right, who pay individually the highest costs, who bear the heaviest burden economically of conflict at 12% of per capita GDP. So these are really helpful ways of disaggregating data, getting comparative perspective, just looking at the problem from different perspectives starts to open up questions that we can pursue, problems that we can try to resolve, intellectual problems as it were, Like, earlier when the professor said, I just wanted to, try to do this one thing within the climate change problematique, which was, kind of come up with an equation that would estimate the net carbon balance. And I couldn't do it because of the data. But that's what we're talking about here. What he proposed is only made possible by doing this sort of thing, by complexifying, seeing all the ways in which these things play out, manifest, matter, can help us bring into focus ways we can start to tackle them. Right? So let's use the insights of that data that we've been looking at and these questions that we've been reframing to start to begin to model in more complex ways. Okay, so we have about 3 slides left, and then we're going to export this to video and send it out. So what I'm showing you here, the question is, why are some wars far more intense, long-lasting, and destructive? What explains the variation in what I refer to as war magnitude, right? Or conflict magnitude, right? Now, what does that mean, right? We were working with just casualties, but then I started to get you to think about, the economic costs of war, but there are many, the environmental costs of war, the cultural, social costs of war, right? So we can should recognize, importantly, that the thing I'm interested in, the problem that I'm pursuing here, the variation in the consequences of conflict, the magnitude of conflict that varies, is itself a construct that has multiple components to it. It's about fatalities, it's about economic costs, it's about the environmental costs of conflict, etc. Right? So we have a kind of multi-dimensional outcome that we're trying to grapple with. What gives rise to it? What explains why magnitude, defined in these multiple ways, varies across situation, across conflict, right? Well, what I've proposed here in front of you, if you kind of remember your methods, are some explanatory variables, right? Let's just look at them, and they'll make perfectly, good common sense, right? Conflict duration. The longer a conflict lasts, it makes sense, it stands to reason, the higher the conflict magnitude will be. What about the sizes of the armed forces engaged, right? So the more soldiers, the more tanks and planes and bombs that are, right? The more of those, the more magnitude. Again, stands to reason, right? International intervention, and again, by that I mean like Russia and Syria, and U.S. and Libya, or whatever. Right? That kind of international intervention, as I've pointed out, tends to have the effect of prolonging war and thus increasing magnitude. Russia is responsible for the U.S. has done many things wrong in Syria, but I think it's on the right side there, right? We're not always and haven't always been on the right side of things. We were not doing it well, but we were on the right side in Syria. We weren't flying, Antonov bombers and rolling barrel bombs off the back of the plane into civilian neighborhoods. But that's what the Russians and Assad's Air Force was doing, and it still is doing. And it's that kind of international intervention that increases the magnitude of conflict. What about peace operations, however, right? I've done a fair amount of research on this question, as have many, and there's a great deal of evidence that for all of their shortcomings, and they are legion, peace operations do tend to have a depressing, in a good way, a depressing effect on conflict magnitude. It tends to reduce the magnitude of conflict in terms of fatalities and duration and a number of it's spread to other countries, all of that. So peace operations. And then finally, conflict termination by victory. Conflicts end in different ways. They end by negotiated agreements, they end by victory, different ways. It turns out, right, that conflict by victory is associated with a lower level of conflict magnitude. They tend to end more quickly and thus kill fewer people. That's led to some controversial propositions about what we should do in terms of peace operations, but that's kind of beyond us here. So what we have, right, what you see here, right, are some explanations for the thing we're trying to understand. Now, you know what this is, right? Now, you don't know that what it's called in this context is building what's called a path model, but it's a form of complexity that you'll come to appreciate. We have a dependent variable, or that outcome we're trying to understand, right? And we have the independent or causal variables that we reasonably stipulate or propose as explanations for the variation in conflict magnitude. We also have what are called, in a path model, path coefficients. You'll notice that those lines were associated with a positive or negative. Quite simple, right? Conflict duration, the more, the more. The longer it lasts, the greater the conflict magnitude, right? A negative is, the more of one, the less of the other, right? So the more we engage in peace operations, the lower the conflict magnitude tends to be. The less, so we have path coefficient. If that language, that term path coefficient doesn't mean anything to you, just think back to that line equation. I'll show you again in just a moment, right? Okay, it's very, very simple, right? Here's some just made up data. It's hypothetical in some sense. Right? Imagine in Thailand, that a key financial donor to the government, to the junta, is getting upset about whatever it may be, the spread of prostitution or sex tourism or whatever it is. A key donor, somebody that gives the ruling party a lot of money, starts to make kind of more frequent comments about maybe reducing the level of donations to the government, right? Campaign finance donations. You can imagine that would lead to changes in what the government might be doing, right? So what I've got here is just some hypothetical data, right? Threats that the Prime Minister receives about losing campaign donations from this, quote, Miss Y, a kind of made-up character, right? The more Miss Y threatens to quit giving money, quit giving financial contributions, right? We start to notice more raids on brothels or bars or whatever, and more prostitutes, more sex workers, more bar girls or whatever they're called, getting arrested, right? Over a given weekend, right? So we have this data. When there was one threat, there was 1.05 arrests. When there were 5 threats in a week about reducing the campaign contributions, there were 5.25 arrests over that following weekend. And when there were 14 threats to reduce their campaign donations, there were 14.7 arrests, right? So you could imagine plotting that out, couldn't you? And there's that same formula again, y equals ax plus b, right? Well, all I'm telling you here, I just made up all this data, right? But all I'm doing is telling you that coefficient, that term coefficient, is what tells us is about the steepness of the slope of that line, whatever that line is, right? So the bigger the coefficient, the steeper, the steeper the slope, the more significant, the more powerful the relationship might be, right? So you can see that this coefficient is, for every threat to withdraw, there is a 105% increase in the likelihood of another arrest of a prostitute, right? So the coefficient is simply just scientific statistical language for just, what is the relationship between things we're trying to understand. That's all that means. So let's get back to this model, and I'm going to send this out and make it available to you. So we're going to kind of flesh out the rest of this model in a brief kind of way. What I've already introduced to you is the language of mitigating and mediating variables. So in a complex model, and path models are a form of complexity, we see the inclusion of 2 new kinds of variables. Now those, we've all had methods courses, and we've had independent and dependent variables, right? Now we're going to start talking about additional kinds of variables, those mediating and mitigating variables, and the ways in which we can talk about direct effects between variables and indirect effects, right? So before we even add more variables, let's look at the ones we already have on the table. We said before that conflict duration is positively correlated with conflict magnitude. It's a positive path coefficient there. So that positive blue line between conflict duration and conflict magnitude tells us that. That all makes perfect sense. But isn't conflict duration itself the result of things? Don't other things on their own explain the variation itself in why do some conflicts last longer than others? Well, absolutely. And we can talk about the things we've already said. The intervention by Russia and the US only had the effect of lengthening the Syrian conflict. Peace interventions can have a negative effect on. So intervention of external states can increase duration of a conflict. Peace operations can reduce it. Conflict termination by victory can shorten a conflict, right? Whereas having strong, deep religious sectarian divisions in society can lead to a civil conflict lasting much longer than that which takes place in a society without deep religious sectarian kinds of divisions. So conflict duration has a direct effect on conflict magnitude, but conflict duration itself is the result of other factors, and so we'll start to see that variables have direct and indirect effects. And then these interactive effects. Conflict duration is itself determined by other variables that have their own independent effects, as well as the effect on conflict duration, which has its very important independent effect. This is where we get to with mediating and moderating variables, those which can limit the strength of the causal relationship between conflict duration and magnitude, for example, or strengthen it, right? So the final shape of what a fully fleshed out path model looks like is this, right? Now, don't freak out on this. Just kind of appreciate, I think, its beauty, right? And I don't mean that because I just worked my butt off in estimating these equations and coming up with this model. I just think it's when I say beautiful, I mean in a kind of explanatory sense. There's a beauty to its elegance, to its parsimony. So what we have here are. It's hardly complete, it's hardly fully fleshed out, right? But what we have is on the right, that thing we're trying to understand, the variation in conflict magnitude, right? And as we go to the left, we have these independent variables, and further back we have variables that are ultimately some of the root causes of the independent variables that we had already identified. So let's start now on the left, right? We have things like geography, right? We know, and again, I said like point 2 is we do a literature review to kind of get what the risk factors are. Well, it turns out that one very important risk factor for violent, lengthy civil wars is the nature of the geography of the country involved. When the geography is such that it's hard for the government to reach where the rebels are forming, the conflict goes on. So geography matters. Primary commodity export dependence. Countries that are highly dependent on diamond exports, gold exports, have, a tendency to have, conflicts. The capacity of the state to govern well, the societal capacity, the civil society, regime type, democracy versus, autocracy, regime consolidation. Are they stable or are they changing in one direction or the other? How much corruption is involved? Inequality, and there are 2 kinds that we can talk about at greater length. And then remember the kind of regional comparisons that we did, right? So we're looking at conflicts in the context of Africa, South Asia, Latin America, Europe, Asia Pacific. What we have here, right, is the beginnings of complexity in terms of explanation, right? It's all moving in one direction, and that's where a complexity science model will differ, and that's what we're going to do in the second half. But what we get with a path model is the kind of multivariate meaning multiple variables that need to be identified, the various relationships and interrelationships among those variables, or feedback loops as we've called them, right? That all must be accounted for if we want to meaningfully grapple with the problem we want to grapple with, right? Take some time. This might be a time to just pause the video. We're at the end of it, actually. This is just one more slide. This is the last substantive slide. Take a moment and just kind of study this slide and look at the path coefficients. Look at the legend. Right, we've got pink lines that are said to be kind of weaker relationships. Green lines denote or connote medium strength relationships, and red lines denote, or orange lines denote, kind of strong relationships. Look at the ways in which variables directly impact the outcome and indirectly, and then interrelationships among them. Study this for a little bit, and I think you'll start to feel what complexity explanations and complexity science is all about, and that's what we're doing. Okay, so file that conflict data away. We'll be coming back to it, as I said, but in the second part, we're going to be talking about the weather, or climate, actually. All right, ciao.